So we started looking at quadratic functions, and we said that in general, a quadratic function has the type of form of ax squared plus bx plus c. A, b, and c are numbers, a is not 0. And sometimes they're written in this form, y equals a times x minus h squared plus k, where this h here and this k here make up the vertex. And that a out front is sometimes called the scaling factor. It also determines the orientation, right? If it's positive, it opens upwards. If it's negative, it opens downwards. So that's a review from the first video. Okay, so sometimes you have your quadratic function. When you graph it, it's a parabola. Sometimes you have this function that's in the general form, the first form, and it's not easy to pick out the vertex because you don't have an h and a k. So there's a formula for finding the vertex, and the formula is right here, the vertex formula. So your x-coordinate is going to be minus b over 2a, and your y-coordinate, to find your y-coordinate, you just plug it back into the function, then the minus b over 2a back into the function to find the y-coordinate. So let's actually look at this and do an exercise. I'm going to ask us to find the vertex of the parabola. So the parabola is the graph of the quadratic function. Find the vertex of the parabola. The x-intercepts, which we know how to find x-intercepts from our previous unit on functions, and the y-intercept. We know how to find the y-intercept from our previous unit on functions. Sketch the graph of the parabola and include these points. What points? I guess the vertex, the x-intercepts, and the y-intercept. So altogether, I think that's a total of 4 points. Vertex, 2 potential x-intercepts, and 1 potential y-intercept. That's 4 points. Okay, so here we go. There's our function, f of x. Okay, actually, they're calling it y here. Y equals negative 2 x squared minus x plus 3. So the first thing we want to do is to find the vertex. So the vertex formula is going to be minus b over 2a, comma, f of minus b over 2a. Okay, so basically f of x is the same thing as y here. So the first thing I'm going to do, I'm going to look at a, b, and c in my quadrant. Well, I don't need c, I just need a and b. So a here is going to be minus 2. That's the number in front of the square term. And b is going to be the number in front of the x term. It's going to be minus 1. So b is minus 1. So now for the vertex, I'm going to look at minus b over 2a. That's going to be minus negative 1, I'm plugging in for b. 2 times, and then for a, I'm plugging in negative 2. So negative 1 is positive 1, right? Double negative makes a positive, and 2 times negative 2 is negative 4. So for my x-coordinate here, I have minus 1/4. Okay, now we have to find our y-coordinate. To find our y-coordinate, we're going to take f of that. F of minus b over 2a. So f of minus b over 2a is f of minus 1/4. So we're going to plug minus 1/4 back into our function. So we have, let's see, negative 2 times a blank squared minus a blank plus 3. Everywhere I have an x in my function here, in blue, I'm going to put a minus 1/4. doing this computation. It's our task right now. So we're going to have minus 2 times, let's see, negative 1/4 squared is positive 1/16. And we have a double negative, so there's going to be a positive 1/4 plus 3. Let's see, negative 2 times 1/16 is minus 1/8 plus 1/4 plus 3. So this is going to be, find a common denominator of 8. You're going to have minus 1/8. So 1/4 is the same thing as 2/8. You multiply the top by 2, the bottom by 2. You get 2/8. And 3, you can multiply, imagine this is 3/1. So 3/1 is the same thing as 3, where you multiply the top by 8, the bottom by 8, and you get what? 24/8. So I'm going to have that, that's right here, 24/8. So I'm going to have over 8, negative 1 plus 2 plus 24, some basic arithmetic using fractions. Negative 1 plus 2 is 1, 1 plus 24 is 25, so I got 25/8. So 25/8, what is 25/8? It's going to be 3 and 1/8, right? 3 and 1/8, okay. So 3 and 1/8. So we have minus 0.25, comma, 3.125. That's our vertex. Now let's find the X-intercepts. The X-intercepts. Let's find the X-intercepts. So to find the X-intercepts, we're going to set the y equal to 0. So we're going to have 0 equals minus 2x squared minus x plus 3. So I'm going to get rid of the negative out in front of the minus 2x squared. It's kind of not nice to have a negative there out in front of the 2x squared. So we're going to multiply everything by 0. We're going to get 0 equals 2x squared plus x minus 3. Yeah, so I just multiplied everything by negative 1 to clear out that negative in front of the minus 2x squared. So now we have a positive 2x squared plus x minus 3. So now I can factor this. So you could factor this or use the quadratic formula to solve. I'm going to factor. So I'm going to put here 2x and a 2x. I'm going to find two numbers that multiply to give, let's see, 2 times negative 3 is negative 6. And two numbers that also add to give the middle number here of 1. So what two numbers multiply to give minus 6? That should be a minus 6 right there. And add to give a positive 1. Well, you could say, let's see, positive 3 and negative 2 multiply to give minus 6 and add to give positive 1. So I'll put a positive 3 here and a minus 2 here. And then you have to remember to divide out anything in common between each individual factor. So the first factor, the 2 and the 3 are not in common. Well, you can see here there's a 2 in common between the 2x and the minus 2. So you divide out a 2 there. So we're going to have 2x plus 3 is the first factor. That hasn't changed. But the second factor is going to be x minus 1. So we have 2x plus 3, x minus 1, and then you set each factor individually equal to 0. The second one's easy. You add 1 to both sides and get x is 1. And this first one, you subtract a 3, get 2x is minus 3, and divide both sides by 2, you get minus 3 halves. Or you could say, right there, you could say that's minus 1.5. It's another way to write that one. And I don't know what's going on with my screen there. That's better. So Now to find the y-intercept, we know how to do that. We set the x value equal to 0. I have y equals, what's my function? Minus 2 times blank squared minus blank plus 3. Everywhere we have an x, we're going to put a 0. It's just going to give me y equals 3. So I have a y-intercept at 3. All right, so here we go. We are going to plot everything. Let's see, how big do I need to make this? X-axis, y-axis. Let's start with the vertex. Remember what the vertex was. It was minus 0.25 and 3.125. So I'm going to, let's say this is negative 1, negative 2, 1, 2, 1, 2, 3, 4. Not with a good scale, but anyway, minus 1, minus 2, minus 3. So starting with the vertex. The vertex was minus 0.25 on the x and 3.125 on the y. So that would be here, here. So maybe right there. Oh, come on. So minus 0.25 for the x and positive 3.125 for the y. Okay, so that's my vertex, the red. Well, we got the vertex. Now let's use the x-intercepts. So we're going to have a positive 1 right here on the x-axis. And we're going to have negative 1.5 over here on the y-axis. Okay? And what else do we have? We're going to have a y-intercept right here of 3 right there. So putting all this together, our graph is going to do something like that. Now, how do we know it was going to be an upside-down parabola to begin with? How did we know that? How did we know it was going to be upside down and not a right side up parabola? Well, it's upside down because if you go back, you look at the very beginning, this is a minus in front of the square term, right? The square term has a minus. So that's your a. That's your a there in front. And anytime your a, like ax squared plus bx plus c, the a is negative, you know it's going to be upside down. All right, so there we have it. Nice. So that's some more graphing when you don't have it already in the vertex form. So this one was not in the vertex form, it was in the general form. Let's do another one. A little bit different instructions maybe. This one says find the vertex of the parabola and sketch its graph. It doesn't say anything here about finding the x-intercepts and y-intercepts, notice, so you're not required to find those. Include 4 additional points besides the vertex. Okay, so we're not finding the x and the y-intercepts, the x-intercepts and the y-intercepts in this one. So here the function is y equals 3x squared minus 6x plus 1. That's the parabolic function. It's a quadratic whose graph is a parabolic function, parabolic graph. Now, we can already tell that this one's going to open upwards. How do we know it's going to open upwards? Because this 3 out front is positive. So we know it's opening upwards. Now let's find the vertex. The formula is what? Minus b over 2a, and then f of minus b over 2a. So let's say a is 3, b is minus 6, c is positive 1. We don't even need the c though. Yeah, c is not necessary. You don't need c for finding the vertex. You only need a and b. Okay, so let's find minus b over 2a. That'd be minus negative 6 over 2 times 3. In other words, 6 over 2 times 3 is 6. 6 over 6 is 1. So then we got to find the y-coordinate, so we're going to find f of minus b over 2a, or simply f of 1, I should say. I'll just write it as f of 1 is the quick way to do it. All right, so we're going to take our function 3 times a blank squared minus 6 times a blank plus a 1, and we're going to plug in an x-coordinate of 1. That's going to give us 3 times 1 minus 6 plus 1. In other words, 3 minus 6 plus 1. In other words, 3 minus 6 is negative 3 plus 1 is minus 2. So we're talking about 1, negative 2 for a vertex. Now, we're not finding the x-intercepts where it crosses the x-axis. We're not finding the y-intercepts where it hits the y-axis. We're just going to find additional points, 4. Now, how are we going to do that? We'll look at, so we already have f of 1 is minus 2. Let's look at f of 0. Let's look at f of negative 1. We haven't done those. Let's look at f of, let's see, 2, and let's look at f of 3. So they're all really close to 1 as x value. So we have x is 1. X is 1 is u, so we're doing x is 0, x is negative 1, x is 2, and x is 3. So f of 0. So we're going to have, let's see, 3 times blank squared minus 6 times blank plus 1. So we're plugging in here 0. And that's simply going to give 1, right? Because those first two terms are going to 0 out. Next, I'm going to do 3 times blank squared minus 6 times blank plus 1. We're plugging in negative 1 this time in blue. It's going to give us 3 times negative 1 squared is 1. Negative 6 times negative 1 is plus 6, and then plus 1. So we're going to have 3 plus 6 plus 1. That's going to be 10. Okay, and then we're going to plug in 2 into our function. 3 times blank squared minus 6 times blank plus 1. We're plugging in a 2. That's blue. That's going to give us 3 times 2 squared is 4. Minus 6 times 2 is 12 plus 1. So we're going to have, what, 12 minus 12 plus 1 is 1. Finally, to plug in 3 into our function, 3 times blank squared minus 6 times blank plus 1. Plugging in the 3 here gives us 3 times 3 squared is 9. 6 times 3 is 18 plus 1. So we got 27 minus 18 plus 1. It's going to be 10. And basically, I have these points, 0, 1, negative 1, 10, from the x and the y values, 2, 1, and finally 3, 10. So I'm going to plot those 4 points in addition to the vertex. So let's start off with the vertex. The vertex was what? Right here. 1, negative 2. So here we go. So 1, what do we say? Negative 2. Okay, that's down here a bit. Right, that's 1, -2. That's the vertex. Now we know this is opening upwards for sure, because remember that the a value, that's the number in front of the square term, is positive. It's a positive 3, so it's going to be opening upwards. Okay, so let's plot 0, 1. That's right there, right? And let's plot -1, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's right here. -1, 10. Okay, let's plot 2, 1. And let's plot 3, 10. And we're going to connect those. And we're going to get our stretched out parabola. Notice it's stretched out by a factor of 3, right? A factor of 3, because we had the 3 for our A right here. And that's it. You got your vertex and then 4 additional points. So we really didn't go for the it turns out we did find one of the intercepts. We found the Y-intercept right here, right? That was 0, 1, but they were just kind of coincidental. We found it along the way.